Welcome back to our daily dive into AI. I'm Raj, a senior data scientist working on deep learning and AI. Let's explore the building blocks of AI one video at a time. Today, we will be talking about multi-layer perceptrons, or also called as MLPs. A multi-layer perceptron is essentially a feed-forward neural network with one or more hidden layers in them. It's made up of layers of neurons, or also called as perceptrons, which each perceptron takes an input and it multiplies by a weight and adds a bias to it. So each perceptron takes an input, let's say a weight, and then multiplies it by a weight and adds a bias to it. So this particular formula happens in every single perceptron. And then it passes it through an activation function. And further we'll understand why this is necessary. MLPs are powerful because they can learn complex and non-linear patterns in the data. So you guys might have all studied in your high school an XOR gate, mostly in mathematics class or in an electronics class. So don't worry if you don't remember, we'll go through it. So an XOR gate has two inputs and one output. Okay, so there are scenarios. 0 and 0 means the output is 0. 0 and 1, output is 1. And 1 and 0, the output is 1. And 1 comma 1, the output is 0. Okay, so this is an XOR gate, an exclusive OR, also called as. So let's see how a multi-layer perceptron works on this one. So a single layer perceptron cannot solve this XOR gate problem because it's not is non-linear in nature. So we definitely need more than one perceptron to solve this problem. So that's why we want to look into the MLP. So as we know, there are two inputs here, right? So x1 is our input 1 and x2 is our input 2. And the input layer, we have about 2 neurons here. So and then we have one hidden layer. This is the input layer. I will mark it as input 1. And we have hidden layer. Often, there are two neurons in a hidden layer is more than sufficient to solve this simple problem. And then we have the output layer, O2. So I'll make it as O1, and then we have one neuron. Why in one neuron? Because our end goal is to get only one output, whether 0 comma 1, 0 or 1, sorry. So we basically defined a network here. So we have a set of neurons, two neurons or two perceptrons in the input layer. Further, we have 2 in hidden layer and 1 in the output layer. So we typically apply like an activation function such as sigmoid or ReLU in the hidden layer. The output neuron can also use a sigmoid layer if we want a probability kind of a score close to 0 or 1. So in the forward pass, each input neuron feeds into hidden layer. So let's say each of these input neuron is connected to the hidden layers. The hidden neurons activate and feed into output, the neuron output. So these hidden layers are further connected to output layer, which goes through like a sigmoid or an activation function to determine the output. The output neuron produces the final prediction based on and again on another activation function attached to it. So we further calculate the error in a process called backpropagation. So we calculate the error by comparing the prediction of the XOR label from the network, and then we use an optimizer called gradient descent. So gradient descent algorithm, we will talk what a gradient descent algorithm is in the next future videos. But for now, let's understand gradient descent is a process in which we adjust the weights and biases. So basically, as I showed you the formula here, using the gradient descent, we will adjust these weights and biases across the perceptrons to match the output and over the several different iterations. So this is how an multi-layer perceptron works. Thanks for watching the video. I hope you all liked it. Stay tuned for more AI videos. Thank you.